AP Calculus AB. This is the second video in the introduction to integrating, finding antiderivatives using the power rule, the antiderivative of 1 over x, and integrating sine and cosine of x. If you recall, when you take the derivative, it's measuring a rate of change. And typically, but not always, the original function is a total of something. So that means if we are given a rate of change and we integrate it or find the antiderivative, we're going to find totals, which could be very valuable. So let's look at an example here that's pretty abstract. Use the given information about f prime and f double prime to find f of x. So we're supposed to find f of x. So we're going to start with the only function that we're given, which is f prime. This is not a function, this is not a function. These are ordered pairs. This is an ordered pair for f prime, ordered pair 2, 5. This is an ordered pair for the original function 2, 10. This is a function because it says f prime of x. So we're going to integrate the only function that we're given. We're going to integrate f double prime. When you integrate that, that should give us f prime. So we're going to recover f prime by knowing what the second derivative is. If we integrate this, which is integrating 2, anytime you integrate a constant, you're going to get a linear function. And we have to add in this arbitrary constant. So just to make sure this is clear, 2 is the same as 2 times x to the 0. Add 1 to the exponent, will be to the first. Multiply by the reciprocal of 1, which is 1. 2 times 1 is 2. It could have been plus 0 in this, so we add this constant in. Now, how do we figure out what the constant is? I'm just going to pose that question. To figure that out, we need an ordered pair that uses f prime. So as far as we know right now, f prime of x is equal to 2x plus c. We have this ordered pair right here. We have the ordered pair f prime of 2 equals 5. So if we replace 5 in for f prime and the 2 in here for x, we should be able to figure out what c is. So 5 equals 2 times 2 plus c. 2 times 2 is 4. We're going to find that c is 1. So what does that do for us? We can conclude that f prime is 2x plus 1. It has to be. Has to be because it has to fit this ordered pair, 2, 5. And by putting 2 in for x and 5 in for y, we had one choice for c. So we know that's 2x plus 1. Now we are supposed to figure out what f is. Function f can be found by integrating f prime of x with mad props to x. F prime, we just figured out, was 2x plus 1. If your function's more than one term, you need to put it in parentheses. Integrating 2x plus 1. If we add 1 to this exponent, it's going to be x squared, multiplied by the reciprocal of 2, which is a half. A half times 2 is 1. And then plus integrating 1 is going to give us x. And then we add our arbitrary constant. That's all fine and good, but we have to know what c is. So do we have an ordered pair using function f? We do. It's right here. It's 210. So at f of 2 equals 10, we would have 10 equals 2 squared plus 2 plus c. So it'd be 4 plus 2 is 6. Subtract 6 from both sides, and we're going to find that c is 4. Once we know that, we could confidently say that the function f is x squared plus x plus 4, which is what the question asks us to find, so we are finished. would be wise if we did another example like this. Same type of problem, we're supposed to find function f. So we're going to find f prime, we're going to integrate f dubs. F dubs is x to the negative 3/2. So f prime of x is going to equal, if we add 1 to the exponent, a negative 3/2 plus 2 over 2 is going to be a negative 1/2. Multiplied by the reciprocal of that, it's going to be a negative 2. Add in your arbitrary constant. Therefore, f prime, I'm going to prefer to write this with positive exponents and actually as a radical. I take the ordered pair I have for f prime, which is f prime of 4 equals 2. I'm going to get 2 equals negative 2 over the square root of 4 plus c. Square root of 4 is 2. Negative 2 over 2 is negative 1. I'm going to get that c is 3. So my conclusion for this is that f prime is negative 2 over the square root of x plus 3. So now I need to integrate that to figure out what f is. F of x is going to be the integral of f prime of x with respect to x. Have this written in an easier form to integrate. So it's negative 2 times x to the negative 1/2 plus 3. More than one term, you got to put it in parentheses. So f of x is going to equal. Add 1 to this exponent, it's going to be x to the 1/2. I multiply by its reciprocal, by the reciprocal of 1/2, it's 2. Negative 2 times 2 is negative 4. Antiderivative of plus 3 is going to be a plus 3x. Then I add my arbitrary constant. There's an ordered pair up here, 0, 0. So if I replace y with 0 and I replace x with 0, I'm going to get that this constant in this case is actually 0. Therefore, f of x is going to equal negative 4 times the square root of x plus 3x plus 0. And we don't need the plus 0, quite frankly, obviously. All right, let's do another. An evergreen nursery usually sells a certain shrub after 6 years of growth and sapping. The growth rate during those 6 years is approximated by the differential equation. This is a derivative of h with respect to time, 1.5t plus 5, where t is the time in years and h is the height in centimeters. The seedlings are 12 centimeters tall when planted at t equals 0. That is super important. That's an ordered pair. The height is 12 at time 0. Also super important that time is being measured in years and the height is measured in centimeters. Find the value of the differential equation above when t equals 3. Using correct units of measure, explain what this represents in the context of the problem. So it's telling us find the value of the differential equation. This is the differential equation using t equals 3. Using proper form, using proper notation, I should say, it's the derivative of h with respect to time evaluated at t equals 3. That's going to be 1.5 times 3 plus 5, which is 4.5 plus 5, which is 9.5. What kind of units are we going to use here? H is in centimeters, t is the time in years. So this is going to be centimeters per year. We're supposed to explain this. So an explanation would be at 3 years, the trees are growing at a rate of 9.5 centimeters per year. All right, part B. Find an equation for h of t, the height of the shrubs at any given year. Then determine how tall the shrubs are when they are sold. So we got two parts. We got to find the equation of h of t, and then we have to determine how tall they are when they're sold. To find the height, we're going to have to integrate the change in the height with respect to time So this rate of change is integrating 1.5t plus 5, more than one term, so put it in parentheses. If we add 1 to the exponent here, it's going to be t squared. Reciprocal of t of squared is 1/2. So half of 1.5 is 0.75. And then the antiderivative of 5 is 5t. And then we add in our arbitrary constant. Now, to determine the actual function, we need an ordered pair for h so we can figure out what c is. And we have that ordered pair right up here. Zero, 12. So we put 12 in for h. We put 0 in for t, which is going to make this super easy to calculate. And we get that c is 12. To answer the first part of the question, our function for h of t is 0.75 t squared plus 5t plus 12. So this answers one part of the question. The second question, how tall, that means solve for h, are the shrubs when they are sold? So when are they sold? Let's see. They sell the shrub at 6 years. So that means we got to figure out what h of 6 is. It's going to be 0.75 times 6 squared plus 5 times 6 plus 12. It's going to be 0.75 times 36 plus 30 plus 12. This is 27 plus 42. So the height after 6 years is 69 what units? Height was measured in centimeters, 69 centimeters. On the AP test, you could stop right here and say this many centimeters. If you did that, you'd put this in parentheses because all of those are centimeters. Sentence answer, at 6 years, the height of the tree is 69 centimeters tall. Or since the question said how tall are when they're sold, you could say when sold, the height of the trees is 69 centimeters tall. All right, let's do one more example. Particle motion, something that we need to make sure that we are excellent at. A particle moves along the x-axis at a velocity that's given here. At time t equals 0, its position is 4. Now that is super important. Typically, the position function we call x for whatever reason. It's crazy. So x of 1 is 4. That is the position. What is the acceleration of the particle when t equals 9? Well, to find the acceleration, that's the derivative of velocity. So the derivative of t to the negative 1/2, I'm going to put the 1/2 in front, subtract 1 from the exponent, So I get my acceleration function. I want to know what the acceleration is at 9. So if I rewrite this like so, hold on a second. There's my acceleration function written in a way that's easy to use. So if I substitute the 9 in for t, I get the square root of 9 cubed, or I can cube the 9 and then square root it. Square rooting it first is going to be easier. Square root of 9 is 3. 3 cubed is 27. So this is going to be negative 1 over 54. What kind of units are we talking about? It doesn't say what type of units. It doesn't say what type of units. We don't have to give units, but let's just say that we want to be a little bit crazy. This is going to measure in linear units per unit of time squared. Acceleration, the time's always squared. So what's the acceleration when the particle is t equals 9? We got it. B, what's the position of the particle when t equals 9? Well, we need a position function. To find a position function, we're going to integrate the velocity. The velocity function was t to the negative half. We add 1 to the exponent, multiply by the reciprocal, and add our arbitrary constant. To figure out what this constant is, we need an ordered pair. And we had an ordered pair up above that was x of 1 equals 4. So I replace x of t with 4, the position. I replace t with 1. 2 times 1, square root of 1 is 1. 2 times 1 is 2. If I subtract 2 from both sides, I'm going to get c is 2. So my position function, officially, is 2 times the square root of t plus 2. What's the position when t is 9? Well, that's going to be x of 9 equals 2 times the square root of 9 plus 2. That's 2 times 3 plus 2. That's 6 plus 2, which is going to be 8. What kind of units? We don't know. Its position. It's going to be some type of linear unit, and we weren't told what it was. That concludes the notes. Hopefully that made some sense. Sorry about the interruption in the middle. Maybe I'll edit that out. Maybe I won't. That concludes 6.1, Introduction to Antiderivatives.